So what we did was कि पहले तो वो starting with the first thing you had electrophilic substitution, right? You had bromination and you had nitration, ठीक है? Benzene and the NO2 would the electrophile will get attached, ठीक है? That's electrophilic substitution. And then you had benzene derivative compounds. उसके अंदर what happened was that you had electron donating groups that they were 2,4 directing groups. What happened was that if you have a group that has a tendency to push electrons onto the benzene, so the electron density was higher in positions where 2, 6, and 4, right? And so the electrophile, when it comes in, it's going to get attracted to positions 2 or 4 or 6. 2 and 6 are kind of the same thing, ठीक है? Same with nitration. The electrophile NO2 will get pushed to positions, it will be more attracted to positions 2 and 4. ठीक है? और फिर you had phenols. Phenols were and phenylamines. They were groups that were also 2,4,6 directing. ठीक है? They were also इधर मैं लिख भी देता हूँ कि they were also 2,4 directing groups. They were the same electron donating groups. But over here, in the case of phenols and phenylamines, the effect was a lot greater. That the electron density was significantly higher. OH group has a large electron rating effect. Lone pair, this should be lone pair. एक second, इसको ठीक करना है. अच्छा, so the lone pair on oxygen in OH group overlaps with benzene's pi electron cloud. Benzene is activated. Overall, benzene pi electron density is significantly higher, stronger attraction for electrophiles. So when you do bromination for phenols or for phenylamines, what happens is that the you don't even need a catalyst. The reaction is a lot faster, and the bromine is so attracted to the benzene that it gets attached to all three positions. ठीक है, that was the reaction of phenols. And with nitration, what happened was that you didn't need concentrate nitric acid or sulfuric acid, and temperature did not have to be 55. You could use dilute nitric acid, and at least one of the NO2 will get attached to the benzene. And if you use slightly more concentrated nitric acid, then it will get attached to all three positions. Okay. Is this clear?
Yes, sir.
So, और ये मैं यहाँ पे I'm not going to I'm not going to repeat for phenylamine, but it's going to be the same. Okay. So you're going to have the same reaction for phenylamines. And nitration of phenols, again, it's going to be the same reaction for phenylamine. The electrophilic substitution reactions are going to be very fast for both of these compounds. Both of these compounds are going to behave in kind of the same way. ठीक है? अच्छा, so that's one part. We did phenylamines, phenols, and we did alkylamines. ठीक है? We did these three. Uh, I mean, these three are the only ones in the course. I mean, remember, these are all, I mean, actually, these are all amines. That's a secondary amine, that's a tertiary amine with two carbon chains. OR is not really in your course, so we can ignore that. Methyl or alkyl is kind of the same thing. ठीक है. अच्छा, now we're just going to briefly talk about the three positions, the 3,5 directing groups. So what do they do? So the next one is the 3,5 directing groups. These are also known as deactivating groups. They're electron withdrawing groups. Once again. So these ones are electron withdrawing groups. So what kind of reactions do they do? So if you have a benzene, and so let's say I've got this benzene with the benzene ring. एक second इसको center में कर लें. अच्छा, with a benzene ring, and just make it slightly smaller. So I've got an electron withdrawing group. Let's say I've got an electron withdrawing group attached to it. What's electron withdrawing group? Anything that's like the NO2 group is. And I'm going to write down the list. The list is already written, TK, for electron withdrawing groups. It's over here. I'll just copy this. So all these carboxylic acid, nitriles, and nitro groups. Remember, this is not an amine, TK. This is an ammonium ion, basically. One second. Okay, so these are your electron withdrawing groups. So let's say, for example, I pick NO2. I said these groups we're not going to study in detail. What you just need to know is that Na2 has an electron withdrawing effect. So now the opposite will happen. The positions where the electron density was higher, in those positions, the electron density is now going to be lower because the electrons are going to get withdrawn. So the right side of benzene, it's going to have a lower electron density because the electrons are going to be pulled away from benzene. ठीक है? Is this ये चीज clear? Is this clear?
Yes, sir.
And the electrons from the extreme left will also kind of get pulled. So the electron density is also going to be lower at position 4 as well. So as a result, by default, the electron density is actually now going to be higher at positions 3 and 5. I mean, relatively higher. So you're going to have a much higher electron density at positions 3 and at position 5. So the electron density is higher at position, and you just write 3. You don't write 5 because 3 and 5 are kind of the same position. ठीक है, अगर उधर से काउंट करें, counting from that side, that's 3. If you're counting from this side, then this is 3. So unless both sides have to be numbered, then it's going to be 3, 5. Otherwise, it's just going to be 3. So the electron density is going to be significantly higher at positions 3 and 5. Now, but overall, in the benzene would be deactive. So overall, the benzene is deactivated. Overall, the benzene electron cloud would have because the electrons are getting withdrawn. So overall, the charge density is lower. And less attraction for electrophiles. So the reaction would become much more slower, less attraction for electrophiles. Okay, so make sure you keep this in mind. So if you have a benzene, let's copy. So if you have a benzene, then let's take that. And if I brominate it, the first thing is I would need all sorts of, I mean, the conditions, you would have to use the catalyst conditions well, based on this. Okay, based on this, um, you would need a catalyst for the reactions to work, and you would need higher temperatures. So the conditions are not going to be milder in this case. So if I do bromination of this or if I do nitration of this, all I need to keep in mind is that, for example, if I do bromination, Then although the reaction conditions are not in your syllabus for this one, but you just need to have an idea that the conditions are going to be a lot strong. You would need a lot stronger conditions for this reaction to happen. So you would definitely need a catalyst. FeBr3 catalyst is required, and maybe you would have to heat it as well because uh so ठीक है, remember iski you don't need to remember the conditions for this one, but you just need to know the idea that the conditions are going to be a as a product क्या होगा, the product is going to be, sorry, one second. So the product in this case will be that the bromine will get attached to position 3 or the other position which is also 3. ठीक है, is this clear?
Yes, sir.
So we're basically done with electrophilics. This is like the entire electrophilic substitution. As I remember, we're not studying this syllabus wise. We're studying it by the way the question is going to be set up. Okay. So I mean we've done a lot of groups, all of them together. Okay. So we've covered electrophilic substitution of the entire chapter in one go. So इसके अलावा we'll just do some questions. One second, let me. अच्छा, so questions the chemistry में they're always mixed, so we'll just focus on one second. Where's the workbook? I'm going to send the workbook as well. Uh, is this one? अच्छा, so starting with, as we'll directly start off with electrophilic substitution of. So he's saying, अच्छा, sorry, नहीं, we've actually missed some reactions. I mean, there's still some reactions left. Well, I just saw that. I said there are actually two more electrophilic substitution reactions. ठीक है, there are two more electrophilic substitution reactions, and those two are, there's a reaction called alkylation. So now alkylation is, उसके बाद फिर करेंगे. अच्छा, alkylation is a very important reaction because that attaches an alkyl chain to the benzene. And this is also electrophilic substitution. So when you have a benzene, so I'm just gonna pick a normal benzene. So if you have a benzene and with the benzene ring, I want to attach a carbon chain to it. What I'm going to do is I'm going to take a halogenoalkane. So the halogenoalkane is going to have, let's say, a Cl, and it's got all these H atoms. So that's your typical primary halogenoalkane. It could be any halogenoalkane. Now what happens is that there's a carbon atom over here in the halogenoalkane, and that carbon atom has a positive charge. So this carbon atom over here, it's got a slight positive charge. Why? Because the Cl is electronegative and the Cl is pulling electrons. So the positive carbon atom is going to get attracted to the benzene. It's going to get attracted to the benzene, and the Cl is eventually going to get. It's going to take away the electron. It's going to get knocked out. ठीक है? I'm going to draw the mechanism later. So what happens is that this particular carbon atom goes and attaches to the benzene. Mechanism इसके बाद draw करता हूँ. So the product is going to be the Cl is going to be repelled by the electrons in benzene, and this particular carbon will then eventually इस H को side पे कर लेते हैं. ठीक है, I'm going to put this H over here, and this goes and attaches to the benzene. And for this, you would need a catalyst as well, because remember, benzene does not have a very strong polarization effect. So you need a catalyst, and the catalyst is going to be the same catalyst that we studied earlier. It's AlBr3 or FeBr3. ठीक है, is this clear?
Yes, sir.
So, and they might as well ask you for the mechanism for this. So what you're going to write is that so I'm going to draw the mechanism for alkylation, which is again electrophilic substitution. So it's going to be two steps. I mean, for this one. So the mechanism would be that in the first step, the electrophile will be generated. So how is that produced? Because so this halogenoalkane, which is what CH3, CH2, CH2, and Cl. It goes and reacts with. Sorry, ये Br नहीं होना चाहिए था. This should be because we've got a Cl, so this should be AlCl3 or FeCl3 because it's a chloroalkane. We don't want bromine to come in. So anyways, so it reacts with AlCl3. AlCl3 is going to polarize this molecule and it will take away the Cl and bond with it. So the first step is that a carbocation gets produced. So it's going to produce CH3, CH2, CH2 plus 1, and the Cl gets knocked out and it's going to be AlCl4 minus 1. The Cl is going to go and form a dative bond. It's going to form a dative bond with the Al. So that's the first thing, and that's your electrophile. This is your carbocation, and that happens to be your electrophile. Okay. And then in the next step, you have to draw the mechanism. The electrophile attacks. So I'm going to take this benzene and copy it. Okay. So this benzene gets attacked by the carbocation. So the carbocation, which is what CH2 and CH3, the positive carbocation is going to take away electrons from the benzene. It's going to go and bond with the benzene. So ये जाता है and it goes and bonds with this benzene. So this carbocation is now यहाँ पे it's bonded to this benzene. Is that clear?
Yes.
And there's an H already there. ठीक है, the benzene electron cloud is going to become partial. ठीक है, it's going to get a positive charge. Why? Because this carbon took away electrons from this carbon over here, which was contributing electrons to the pi bond. So the pi bond is now missing over here because this carbon took it. So where would the benzene take its electrons back from? It's going to take it back from hydrogen. ठीक है? The H is the one that would lose electrons. And where will the H go? The AlCl4 minus 1. Okay, so the AlCl4 minus 1 with its electrons, with the Cl with its lone pairs, it's going to get attracted to the H and HCl will be formed. So next step है कि you will get your product, which is that the H is going to leave. ठीक है, the benzene will get its electrons back. So hold on a second. So benzene will get its electrons back. And where did the H go? The H ended up forming, getting attracted to the Cl over here. It will form HCl. And the AlCl4 turns back into AlCl3. So the catalyst reforms. ठीक है, so that's how your carbon chain gets attached to benzene. So that's the second step. So again, the mechanism for alkylation is exactly the same. It's electrophilic substitution. There's a halogenoalkane. The catalyst takes away the Cl, so it polarizes the halogenoalkane further, turns it into a carbocation. Once the carbocation forms, it goes and attaches to the benzene in exactly the same way as some last time NO2 or bromine was getting attached. Is this clear? This one? ये clear है सारों को?
Yes, sir.
ठीक है, आमना मिनाइल इसी तरह
Yes,
से.
sir.
Okay. So this is alkylation. And then there's another one which is similar to this, and that's called acylation. ठीक है? So which is kind of exactly the same. So but the name is acylation. As in acylation, what happens is that let me tell you what an acyl group is. First thing. So acyl group is this thing. It's, for example, it's like a carboxylic acid. For example, I've got a carbon chain, and then there is all of a sudden there's going to be a C double bond O and Cl. There's a C double bond O and Cl. So this thing over here, this is known as the acyl group. Okay, that's what your acyl group is. So it's a carbon chain with C double bond O and Cl. Okay, that's what acyl group is. So acylation is when this thing goes and gets attached to benzene. So everything will be kind of exactly the same. Okay, I just need a benzene. As इसमें भी the first thing is the very first thing. The mechanism of this particular reaction. Again, this is also electrophilic. This is again electrophilic substitution. So it's the same. Now, the mechanism for this first one, step one, the electrophile is produced. You need a catalyst for this reaction. So this, for example, if I pick any acyl chloride like CH3, CH2, C double bond O and Cl. I'm going to react it with AlCl3 or FeCl3. And my electrophile gets produced, which is CH3, CH2, C double bond O, and that's going to have a +1 charge. And with that, it's going to be AlCl4 minus 1 that's going to be produced. So this over here is my electrophile. Okay, that's my electrophile. So that's the first step. I'm just going to copy the rest and just change this. Okay, the rest is exactly identical. The electrophile goes and attacks the benzene. So instead of this carbocation, I've got a CH3, CH2, and the last part, I'm just going to change this. This is going to be C double bond O, and it's got a +1 charge, right? And this thing goes and attaches. So this is actually C double bond O that is now attached, right? And I'm going to change this. This is C double bond O getting attached. Okay, so exactly same thing. The first thing, the electrophile is produced, and then the electrophile attacks and joins with the benzene. Okay, so this is known as acylation. You clear? Is this clear now?
Yes, sir.
ठीक है or इसका ना I'm just going to write the overall mechanism just a second. I'm just going to copy this. You need a catalyst for this. ठीक है, the overall thing is that let's just change this. So this was alkylation with a halogenoalkane, and this is going to be with a double bond O and Cl. You've got an chloride. You get the carbon is very strongly positive, and an acyl group gets added. ठीक है, just and you would need a catalyst. ठीक है, that's the overall reaction for acylation, and above is the mechanism. ठीक है, so alkylation and acylation. ये clear है सारों को? Is this clear? Everyone.
Yes, sir.
ठीक है, now we're going to move to past papers. ठीक है, now I think we've done all electrophilic substitution. ठीक है, if I see something else, I'll add. So over here, what is he doing? He's asking for the conditions for step number one. That is a benzene, so that is acylation happening. ठीक है, is this clear? It's not just an alkyl chain that's getting attached, it's a C double bond O. I mean, it's two carbon atoms, right? So this is CH3, and there's going to be a Cl. The carbon is going to be very strongly positive. So this carbon gets attached to the benzene. Is that clear?
Yes, sir.
So the reagent is this thing. That's an acyl chloride. And specifically, the name for this one, if acyl chlorides are named this way, it's ethanoyl chloride. क्योंकि it's got two carbon atoms, right? So it's ethanoyl chloride. I'm going to write the name in the notes as well that this thing was called propanoyl chloride. So that's how you name acyl chlorides. ठीक है, three carbon atoms, that's propanoyl chloride. Two carbon atoms, then that's ethanoyl chloride. Or you could have just drawn CH3 and C double bond O and Cl. So COCl. Okay, that's the condensed version. And the reaction conditions are that you need AlCl₃ catalyst or FeCl₃ catalyst. That is required. ठीक है, so and remember, okay, there's going to be a lot of AS stuff as well. So I don't know if you remember that much AS. We're going to revise some of the AS. How do you now this step, TK, he's asking for these two steps, and he's asking you to draw H as well. Now that's AS, TK. That's how your A2 questions would go, because there's going to be a lot of AS involved. So we're just going to revise that. Now this is a ketone. How do you go from a ketone all the way to an alkene? Okay, I'm going to open the AS chart. TK, AS में ना we had a reaction chart which would पता नहीं क्या है एक second. It's this one.
Wait, wouldn't it be oxidation first and then reduction?
हाँ so ठीक है. I mean that's not really. See,
Okay.
you have a ketone and you have to reach an
Oxidation to secondary alcohol and then
that's reduction. ठीक है.
reduction.
नहीं, that's reduction. What you're talking what you're saying oxidation? That's actually
Oh, that's reduction.
हाँ.
Okay.
So basically, yeah, no, this is you have to go from ketone. You're going to go back to an alcohol, right? And from alcohol, you're going to dehydrate it to an alkene. I mean, that's how you're going to reach an alkene. Is that clear? So you're going to turn a ketone back into an alcohol. That's a reducing agent required. That's NaBH4 or LiLH4. And then you have to turn the alcohol back into an alkene. So that's dehydration, Al2O3 plus heat. So going back to the question, this is reduction. So let's go with NaBH4. Okay, so my benzene, nothing happens to my benzene. Uh, but this carbon turns into an alcohol, right?
Yes.
And next step, it gets dehydrated. So it's Al2O3 plus heat. So my alcohol turns back into an alkene. Clear?
Yes.
So we've done all the. Remember, there's going to be a lot of AS revision, okay? Because it's AS is going to be a huge part of this. Okay, this one. The mechanism of this reaction is similar to that of nitration of benzene. So there's another electrophilic substitution happening. So draw a mechanism for this reaction of benzene where the SO3H plus 1 ions include all necessary curly arrows and charges. So first thing, the electrophile attracts the electrons from the benzene.
Then there would be like a partial positive charge on the benzene ring,
Yes.
while both the electrophile and hydrogen atom are attached at the same time.
Okay. This is right. And
Yeah.
and the next step is the H. Then remember there are invisible H's over here. Every carbon over here has an H, right? So we show one of them, and then that H loses electrons, right? And where does that H go, by the way? It goes and attaches to
HSO4
my
minus to form
my
H2SO4.
ठीक है, so and it's eventually going to form H2SO4 back again. Achha, write an equation to show how the H2SO4 catalyst is reformed. So yeah, this is the equation that the H plus one goes and joins with the HSO4 minus one. ठीक है, is this clear? That's a total of 4 marks, right?
Yes.
I said next one. This is Abhi, we just did that. What happened over here? An alkyl chain got attached, right? But clear, there's an alkyl chain that's getting attached in this reaction, right?
Yes.
So what would be the reagent for this? So
Haloalkane.
ठीक है, so there must be a Cl over there as well. So the reagent would be C12H25, and it's got to have a Cl with it as well, right? And the condition is that you would need an AlCl3 catalyst. Is that clear? And the mechanism for this reaction is what? Electrophilic substitution. ठीक है? Is this clear? So Espera, let me just about heat. Is he giving marks for heat? 1 second. Summer 1941. Just 1 second. 141. Just give me 1 second. So which question was this? 1 second. Do we have the question number? I don't think we don't have the question number. Just a second. It's this one. So for heat, plus heat is in brackets. ठीक है. And where's the rest? So we went with. I'm just saying, okay, why? I mean, whether you go for any halogen or alkane, that should be acceptable. Honestly, he gave a bromoalkane, but definitely a chloroalkane is going to be acceptable. ठीक है? Is that clear?
Yes, sir.
बल्कि इधर ना, because he did write heat in brackets, so we can just add heat in brackets. Didn't give marks for that, but we can add heat over here. ठीक है? I said next one. और ये इसके ऊपर ना, it could be a bromoalkane, it could be a chloroalkane. That's both of them are fine. Next one is, now this one, benzene reacts with bromine in the presence of an ammonium aluminium bromide catalyst, AlBl3, to form bromobenzene. This is a substitution reaction. No addition takes place. Explain why no addition. It's just a 1 mark question. Why does it addition happen in uh, in benzene? वो क्या मैंने explain किया था? Why does it was right at the start somewhere that I did explain somewhere over here that, I mean, remember over here in alkenes you had electrophilic addition. Why did you have electrophilic addition? Because when there was a positive charge on the carbon, that positive charge had a pretty high charge density. So it very strongly attracted the Br minus one, and therefore you had an addition reaction. Is that clear? But in benzene, what happens in benzene? In benzene, again, you have a positive charge on the whole benzene ring, right? But the positive charge over here has a very low charge density. It's got a very low charge density, which is why, and why does it have a low charge density? Because it's distributed over 6 carbon atoms. Uh, like when the bromine takes away electrons from this carbon atom, the positive charge kind of gets neutralized by all these electrons over here. So the positive charge has a very, very low charge density, and it's not on any one of the carbon atom, it's kind of distributed. Is that clear?
Yes, sir.
So that's why the positive charge over here is not going to attract this Br minus one that strongly. What that positive charge does is it simply just attracts the neighboring electron. It's not going to attract the electrons like really far away from. So the other Br minus one that's really far away, that's not going to get attracted to this positive charge. So the positive charge stabilizes itself by attracting the electrons that are like close by from this H over here. The H loses electrons and then it goes away and bonds with the Br minus one. Okay, so is this idea clear that the second Br minus one, why does it not get attached to this benzene? Is that clear?
Yes.
So the answer is just a 1 mark question. So what you're going to write is that the so you're saying benzene reacts with bromine in the presence of AlBr3 to form bromobenzene. So you're just going to write that positive charge density on benzene is stabilized by the benzene pi electron cloud. Is that clear?
Yes, sir.
और बाकी वही है कि he's asking कि Br minus one electrophile is produced, so draw the mechanism. So you're just going to draw the same thing, which is that there's a Br plus one coming in. Electrons get attracted to it. One of the carbon atoms bonds with Br. It had an H as well. The benzene is electron deficient now. The H then loses electrons. And what you get is a complete benzene. And where does the H go? The H,
It forms HBr.
ठीक है. So there were electrons, one of the Br gets attracted to the H and it forms HBr. And the AlBr3 catalyst gets formed back again. ठीक है? Is this clear?
Yes, sir.
I said we're going to do more types of questions because most of these questions are about benzene. We did a lot of derivative compounds as well. So there will be other questions. So we'll do that tomorrow then, ठीक है?
Okay, sir. Love.
चलो. Okay, take care. Allah Hafiz.
Thank you, sir.